Hey, dude, what the frick? What do you think you're doing?
I'm so sorry. I'm just trying to figure out the rate at which the fluid is leaving this water gun.
Whoa, how do you do that?
Fluid dynamics is a sub-discipline of fluid mechanics that describes the flow of fluids. Self-explanatory. Fluid dynamics can be used to calculate forces and movements on aircraft, determining the rate at which a fluid goes through a pipe, and even predict the weather. That's how a lot of weathermen predict the weather. For this video, we're going to look specifically at determining how fluids move through a pipe. This is called fluid flow, excuse me. Let's get right to it. It's going to be really fun, guys. I just want to say I'm really glad that we're doing this topic. It's just really exciting. Are you okay? Are you okay? Stay alive. Stay alive.
Alright, so imagine we have this pipe here, and these dotted lines represent some fluid. Let's say it's Sunny D. Yeah, we got Sunny D here. Now the diameter of the pipe is 0.1 meters, and the velocity that the Sunny D is flowing through the pipe is 4 meters per second. So let's say some time goes by, and the pipe now flows from here to here. So we got this area right here in which the pipe displaced itself. We can call that dx, the distance that it traveled, and then dt, the time that it traveled.
And, as my colleague previously stated, we can use fluid dynamics to figure out the amount of volume the Sunny D is displaced. We call this volume dV. The section dV is equivalent to the area of the pipe times the height of the section, which is dx.
See, now, but I thought area is equal to pi r squared. But then when you find the integral of that, it's dA over dt equals pi dr over dt. And then that goes to uv minus integral v du. And then when you find the derivative of that, it's du equals 1, because, you know, that happens. And then v equals
Alpha.
alpha. Thank you. And then wait, is that right? Wait. That's amperes.
You got a lot to learn, kid.
That's amperes, though.
Why don't you come with me?
Okay. Oh.
So then we can say that dv over dt is equivalent to the area times dx over dt. I forgot the d. You can cut. So to solve for the fluid flow through the pipe, all we have to do is take the cross-sectional area and then multiply it by the velocity at which the Sunny D is flowing. So since we have a cylinder, our area A is equal to, as my colleague stated earlier, pi r squared. So then we're going to want to multiply it by our velocity. And so we get that the change in velocity is equivalent to the area times the velocity, and our area in this case, pi r squared. So now all we have to do is substitute in our variables. So we get 0.05, because the diameter of 0.1 and half of 0.1 is 0.05, squared times 4 meters per second. And so then we get, so you plug in your fancy calculator, your TI-80 whatever, you get that this is equivalent to 0.0314 meters cubed per second. And that is the rate at which your volume is changing in your pipe.
And that's the basics of fluid flow. Be sure to like and subscribe if you like this video. Even if you don't, still like.
Oh my God, my baby! My water just broke! Oh!
It's okay. I can solve this problem using fluid dynamics. You got this. You totally failed.
That one's for you, Aaron Griffin. About to power clean 135. You ready for this?
Dang, it's off the
That
ground.
was a deadlift.
Dang. Dang.
Okay, can we start filming now? Alright, that's it. Hold on. Alright. I got times the velocity. Okay.